In this demo, I'll walk you through a SigNoz chatbot built with LangChain. This chatbot can answer questions about your specific SigNoz instance, specifically our cloud platform, by connecting directly to the SigNoz API via the MCP server. We'll run a quick sample introduction, then dive into how we instrumented this, and finally see the traces and metrics on SigNoz Cloud. Additionally, we'll see the dashboards as well. So here's our simple app, simple front end connected to a back end, running a fast API server with LangChain agents. Let's start by asking our chatbot a few questions about SigNoz. It's using LangChain to orchestrate the reasoning and the tool calls, and the MCP server to query the SigNoz APIs. So first, let's try test. So first, we're going to try testing the connection to our SigNoz instance. And it says that the SigNoz instance connection was successful. This is simply a health check through the SigNoz API. Now let's check something like what are the active services in the last 30 minutes. Great. We see we get one, which is LLM answer tracker with some specific attributes of that. Let's actually try even better, and let's say what are the active services in the last 1 day. Hopefully we should be seeing a list of even more services now. Yep, and as we can see, these are all taken from our specific instance that I've fed into the configuration file for the MCP. Now that's just a quick overview of the things you can do with this SigNoz MCP assistant I just showed you in this demo. The agent is dynamically pulling real-time metrics and traces and data from SigNoz via the MCP server rather than relying on static data. Now, let's jump into our code and see how we specifically set up and instrumented our LangChain application. The MCP server exposes the SigNoz API as a LangChain tool. In this code, we register the tool so the agent knows how to call it and when user queries match. This makes it seamless to query the SigNoz data directly from within the chatbot. So as you can see here, we're connecting to this instance of our MCP, which is hosted on an EC2 server at port and endpoint. And we use the load MCP tools function to actually load all the tools into our agent from this server. Then when we call invoke on our agent, it's able to configure parameters and call the tools as necessary. How we set up instrumentation for this is using OpenInference. So what we're using is our OpenInference.instrumentation.langchain, which is a framework used for monitoring LLM applications that's built on top of OpenTelemetry. So OpenInference is essentially a community-driven product that, like I said earlier, is an attachment or an add-on onto OpenTelemetry that leverages the open source nature of OpenTelemetry to easily track and auto-instrument your LLM applications. In this case, we're using the LangChain instrumenter object from this package, and this will automatically wrap any LangChain related calls, specifically to agents and tool calls, with traces and export them automatically to our desired location of choice. Additionally, you would need to pip install this, as well as pip install all of these OpenTelemetry related features that you might need in a regular telemetry extraction. So you would include the trace, tracer provider, OTLP span provider, and batch span processor. You would need all of these for creating and sending your traces over to your platform of choice. In this case, it would be SigNoz Cloud. What I'm going to do first is call load.env, in which I have my ChatGPT OpenAI keys, as well as my SigNoz ingestion key. Here's standard procedure. You create a resource. I'll give the service name of LangChain MCP OpenInference for this service. Create a provider via tracer provider passing that resource. Create an OTLP span exporter in which you give the endpoint of your specific region. So in this case, because I'm in the US region, I'm passing in .us to the v1 traces URL, and then giving a header of the SigNoz ingestion key and passing that in through os.getEnvironment variable, which will be loaded after I call load.env, load_env.env. Then I create a batch span processor, add that to the provider, and then set the tracer provider. Then here is all I need to actually auto-instrument my LangChain application. I just have to instantiate the LangChain instrumenter object from that import from the open inference import that I specified earlier, and then call instrument on that. As long as I do this at the beginning of my script, and anything else in this script, including any LangChain specific functions like init chat model or MCP tools, these will all be tracked and sent accordingly and automatically by OpenInference. So now that I went over instrumenting the app with OpenTelemetry, every agent step and API call to SigNoz is captured as a trace and exported over to SigNoz Cloud. Let's go ahead and go to our SigNoz Cloud platform and see these traces in action. Okay. Now that I'm here on our SigNoz Cloud platform, let's go over to the Traces tab and see what we did with our traces. As you can see here, there are some info about the traces that were exported from our current interaction with the chatbot. Let's go and check out what this trace is, our query endpoint. When we look into our query endpoint, we see that it contains a LangGraph object. This LangGraph trace is essentially the entire agent trace and workflow of our LangChain system. What we can see here is there are a tool call with an agent call before and after it. What this agent call before the tools does is actually invoke the LLM. When a user sends a query, the LLM needs to determine and configure the query to determine the overall plan for how it's going to call the tools and with what parameters it's going to call the tools with. That's what the agent before these tool calls, this one right here, determines. Then the tool calls are actually called and standardized data is returned. But this data is not human readable yet. In other words, it's not prepared like these formatted responses are. That's what this agent after the tool calls does. After returning the data from the MCP server or the tool calls, the agent after the tool calls uses again the LLM to transcribe that data into human readable format and then sends that response back to the user. If we go into the agent, this would be the agent invocation, then we can see some useful details, which one is call model. And this is the actual thing I had just described, which actually calls the LLM model and passes in the instructions and processes based on the user query what tools to call. You can see there's a runnable sequence, which will give details about the LLM specific entities. For example, in the prompt span, we can see the message content, the metadata, the output value, the service name, and some other key information. And in the chat OpenAI, we can see more details specifically about our LLM usage. Here we can see the model name, in this case GPT-4o. We can see the output response again and the output input. We can also see important information like the output token count as well as the input token count. So how much your token usage is, which is crucial for determining usage and pricing. Now let's go over to tools. And we can see for this specific span, this was the fetch services tool that was called. When we see this fetch services tool, we can see the tool description, fetch all instrumented services from SigNoz, and we could additionally instrument the MCP server itself to reveal more information about what exactly is being called here. However, we've only instrumented the backend, which is calling the MCP server. So unfortunately, we do not have more insight on the fetch services, besides the tool name and the tool description. And again, just like before, we have the agent after the tool call has been processed and the input has been returned from the tools. We have a call model and a runnable sequence again with the similar output or similar attributes as what I had described before. Great. That was the traces that have been exported from our app, our LangChain backend. Now let's jump into the dashboard and see how we can visualize this data and see them through interactive charts. Okay, let's go over to our dashboards section. Over here, you can see I have an agentic AI demo in which we have created a dashboard for you guys to see for this purpose with some key information in it. So let's go over some of these panels. Over here, we can see that there's a latency for call model. And this is essentially how long it's taking to actually invoke the agent on either side of the tool calls, right? So that would be to determine what tools to call, as well as once the tools have returned information, how to format that in a response. And we can see the latency of that over time. As we can see, there are ups and downs throughout the last 3-day period. And from a developer perspective, you would be using this to determine really how fast and responsive your LLM model is. The higher these values are, the more laggy it's going to be for your users, and you can take that into account to either optimize or speed up your LLM model. Over here, we have a similar panel, except for the fetch services tool. So the tool that used to actually fetch the services or the active services in the last 30 minutes or a couple of days, in which I showed you in the demo, we can see that these also took quite a while. This could be either because of network related issues or simply because of how long the SigNoz API tool call really took. And we can see there's ups and downs similar to our call model function. We have input and output token counts total. And this is really crucial for just determining how much tokens your service is really using for all the users. And this could be really good in determining insight for pricing. Additionally, we have an error rate for our model calls. And for example, if our MCP server is rate limited, or really some tool calls fail, or the LLM is not able to respond accordingly, we are calculating an error rate. And we've set a warning threshold at this point right here. And so we can just get a nice visualization that in these spikes above, something is going wrong. And from a developer perspective, we maybe want to go through and see the traces specifically at these times to really get a feel for what exactly is going on. We also get a total tool call distribution as a pie chart, and we can see that testing the connection took almost half of the total tool calls versus fetching services took another half, a little bit more than that. This is also pretty useful just determining what type of tools are being called by your users and if specific tools are being overrepresented in this pie chart, you would want to focus more of your efforts on kind of refining that specific tool. And lastly, we have an overall error rate, which is the total amount of calls that ended in error. And here you see that it's quite high, 92.2%. And this is because we were running some rate limiting tests to make sure that we were getting errors over here. So this is quite expected for us. If you guys were to clone this project and run it your own, you'll be getting much less errors. Additionally, if you see in this panel, we have specific colors for each number. So if our error rate is above 5%, it will show up in orange, versus if it was higher than 10%, which it is, it will show up in red. This is really good just to give you as a developer more insight or just a easier visual feel to these panels. So that's a quick walkthrough of the SigNoz chatbot with LangChain and MCP. We saw how the chatbot pulls live data from SigNoz, how instrumentation makes every step observable, and how traces and dashboards in SigNoz Cloud provide real visibility. You can try this approach for building your own intelligent, observable LLM-powered apps through LangChain. Thanks, and have a nice day.